Hi there, this is the Team 3 project proposal for the Band in a Box. My name is Phil Nisley. My teammates are Dustin Coy and Michael Payton. Okay, our problem definition here, using project management principles: define, design, budget, analyze, select, propose, track, produce, and demonstrate one stringed, one percussion, and one wind instrument that will all fit in a 2x2x2 box, while leaving room for a fourth instrument for our customer Maroon and Gold to perform their hit song Ode to Joy. We're a three-man team, so we have to leave room there in the box for the fourth instrument. Okay, these are our design requirements. We have to design three instruments: one stringed, one wind, and one percussion. And we have to balance our design requirements with the constraints that we have on the pipe and the string, so that we build all three instruments, one in the low range, one in the mid range, and one in the high range. And we have to perform our song with the instruments that we built. These are design goals. Our top design goal is to build instruments that will actually play and produce the frequencies that we want them to produce, so that when we perform Ode to Joy, it actually sounds like Ode to Joy. And we're going to perform all parts of that song using a low-range percussion instrument, a mid-range pipe instrument, and a high-range stringed instrument, while staying within all the design constraints. Okay, now I'm going to hand it over to Dustin, and he's going to go over the proposed design for our instruments.
Thanks, Phil, for taking us through the introduction, problem statement, and goals. Hello, my name is Dustin Coy, and I also want to thank you as well, Maroon and Gold, for allowing us the opportunity to share our proposal for your new instruments as you prepare for your tour. I really think you're going to love what we've come up with. The first design we'll be looking at is called the Devil's Fork, and as you can see, it is a stringed instrument that will be tuned in the high voice range for your song Ode to Joy. The Devil's Fork will be tensioned and fretted to give you that wide range frequency necessary to rock out and, of course, wow the crowds. The instrument is played by pushing down on or fretting the string in a particular area to create the desired note. This next slide gives you a breakdown of the description of the Devil's Fork, including the dimensions we saw on the sketch slide, as well as a list of the necessary construction materials and, of course, the all-important budget we're anticipating to create this showstopper. As you can see, your fork will be constructed of plywood, a peanut can resonator, and a 0.36 millimeter string tensioned between a steel guitar string tensioned between an eye bolt and a wood screw. The expected cost of this incredible instrument will come in well under your $15 budget and get you all the dulcet tones you're looking for. Our next slide identifies the fretted note position, fundamental frequencies, and the string length at the given tension. Note that all necessary lengths are measured from the bridge toward the end of the end nut. Now, you'll also notice that the frequency response curves listed below. In that case, we selected the 0.36 millimeter steel guitar string because it is ideal for the range you're looking to play in. The smaller and larger diameter string information is also provided should you need to replace the string later and your local music shop doesn't have that specific string in stock. Okay, so now that we've seen the high voice instrument, let's take a look at the mid voice instrument we designed for you. For your mid-range instrument, we selected the pan flute, which is a wind instrument, as the best candidate. As you can see, each of the tubes in the pan flute will be cut to a specific length, and as such allow you to generate all the necessary notes to play throughout the mid-range. The pan flute will be a compact assembly, which is possible by closing off one end of the tube and choosing the proper opening sizes. This provides maximum mobility while also being ideally suited for touring musicians who don't want to sacrifice sound quality. The instrument is played by pursing your lips and blowing across the open end of the individual pipes to create the desired sound. As we see here, the pan flute will be constructed of 1/2 inch Schedule 40 PVC tubing held together with an adhesive. Now, the estimated cost of the unit will come in well below the $15 budget, as you can see. Next, we see the wide frequency range the pan flute will provide in your mid-range touring instrument. You can also see all of the individual opening depths as well as the overall length of the individual pipes that are necessary to create those great sounds. Also, once again, you can see the frequency response curve showing the relationship between the pipe length and the frequency, so that should you ever need to find a replacement or perhaps choose to modify your instrument, you can do so. For our final instrument submission, we'll be discussing an instrument we call the hanging bars. The hanging bars is a finely tuned solid bar percussion instrument that gives you a great range of low-end sounds. Each of the bars are cut to a specific length as illustrated in the drawing and are supported with a cantilevered mounting style. This allows us to control size of the overall size of the instrument and yet still be able to provide the necessary frequencies for you to bring the bottom end to both your current and future hits. The instrument is played by striking the bars to create the desired frequency and note. Now, as you can see in the table, the hanging bars are constructed using a board with holes drilled into it to support the individual bars, which are made up of wooden dowels. The budget for this instrument also comes in well below the budget of $15. And yet again, we see the frequency response curve, and you'll notice that we've included numerous different types of material so that should you decide to adjust for different frequency requirements later, you would also have the ability to customize your instrument to those specifications to create that desired sound. So now that we've looked at each of the proposed instruments, let's next turn our attention to the remaining requirements. Here we see a top-down view of the 2 foot by 2 foot by 2 foot traveling cube box, which has the different instruments drawn to scale to illustrate the room that will still be available to you for a 4th instrument at a later date, should you choose to add another. It's important to note that as drawn, the bottom of the drawing is actually the front side of the box, and the top of the drawing is what we will consider to be the back side of the box. In this drawing, we see that the instruments are all color-coded with the corresponding tables that identify each of the individual dimensions and the room that they would take up in the box. As you can see, there is still plenty of room left over for later growth. And finally, here is a review of each of the requirements we've shown that our proposal meets. As you can see, each of the requirements have been addressed through our proposal, and as promised, it will all come in under budget. Alright, so now that we've looked at the details of each of the proposed instruments, their construction materials, budgets and design details, as well as a review of how to play each of them, I'm now going to turn the rest of the time over to a colleague of ours, Michael Payton, so that he can take you through the rest of our presentation. Once again, though, I'd like to thank you, Maroon and Gold, for considering our proposal, and best wishes on your upcoming world tour.
Thank you, Dustin. Now that you've seen our proposed designs, I would like to talk to you about our rationale, technology, calculations, as well as our decision-making process. The Devil's Fork will perform similar to a guitar. The tensions and varied lengths offered by the fretted neck will produce multiple frequencies. The pan flute design is well established throughout history and will allow us to easily tune a wind instrument to the mid-voice frequencies. The hanging bar design will provide a simple design similar to a xylophone while achieving the low frequencies necessary for Ode to Joy. Finally, all of these instruments are cheap and lightweight. The designs and technologies used to produce these instruments are very basic. Nails, string, wood, and PVC pipe are all that are needed to produce them. The result is a durable, cheap, and portable band. As you can see here, we did take considerable time to do calculations to determine the length, tension, and linear mass of the Devil's Fork, the length and pipe diameters of the pan flute, and the length, material, and diameter of the hanging bars. When coming up with the 3 instruments for our final design, we utilized 3 different decision matrices. 1 for the high voice, 1 for mid voice, and 1 for low voice. As you can see here, the Devil's Fork performed much better on our decision matrix for the high frequencies. Having chosen a high voice instrument, we moved on to the mid voice instruments. As you can see here, the pan flute performed best as a mid voice instrument of all of our choices, specifically because of the cost and size advantages it offered. Now that we had chosen a stringed instrument and a wind instrument as our high and mid voice instruments, we moved on to our low voice instruments. As you can see here, we had a tie between two of the instrument designs. Since we needed a percussion instrument, we decided to go with the hanging bars. Our band-in-a-box design with the pan flute, devil's fork, and hanging bars will come in under budget, on time, and produce all the frequencies needed to perform Ode to Joy. These instruments will easily fit into a 2-foot cubed box and will even leave room for a fourth instrument to tag along as a spare. Go maroon and gold!